So welcome to Science Boot Camp. Yay! My name is Maureen Nolan. I'm here from the University of Washington. And I'm just going to do a few housekeeping chores, and then we'll get the conference started. So first, I have to introduce our amazing planning team, and just so that you see who they look like, and we're all in our purple shirts, so if you have any questions during the conference, you can find us. Carrie Anderson. Is she here? No, she might be out in the lobby. There she is. Yay, Carrie Anderson. Yay. Mariah Monroe. Eli Gandor-Rude. There he is out there in the orange shorts. Margaret Bean. Margaret Bean. Back. And Margaret Mellinger. Yay. And Matt Parsons. And we'd like to thank our many sponsors, Institute of Physics, IEEE, Taylor and Francis, Springer, YVP, Annual Reviews, SPIE Digital Library, the Greater Western Library Alliance, the National Network of Libraries of Medicine, University of Puget Sound, University of Oregon, Oregon State University, and University of Washington Libraries. So today we are doing an overview of geology and geophysics, and we're gonna, you can either follow this session today with free time, or there's going to be an optional tree tour with our fabulous Kathy Carr, biology librarian. And dinner tonight is at the UW Club, and drinks are from 5:30 to 6:30, and dinner from 6:30 to 7:30. And we will have a speaker this evening. It's Sandy Doughton, the author of Full Rep 9.0. So that's tonight. And let's see, we are being filmed today. So if you hear you're agreeing to be filmed, so if you have any problem with that, let us know. And the films will be posted online after the conference. Let's see, what else? So as you came in, you got green evaluation forms. There'll be a different evaluation form for each session. Please fill those out, and as you return them, you will get your camp merit badges. We have pins for each session. You have to turn in your evaluation form to get a pin, and they are fabulous. Let's see what else we have. And after the conference, there'll be an overall evaluation for the whole conference, and that will be emailed to you. So the last announcement, we're going on a cruise. Yay! So our sponsors have provided that. It's Thursday evening, and it's going to depart the dock, which will be behind the venue for dinner, at 8:45. It's a 2-hour cruise, not a 3-hour cruise. So it's going to go out into Lake Washington and then come back. So we should be back about 10:45, just so you know. We included a waiver in your packet. That is your ticket onto the boat. So you do need to fill that out, and please return that as you board. I'll take those as you get on the boat. And we're having a break today at 2:30 out in the Commons area. So that will be after all of our sessions today. And I had one more thing on here. Oh, and in the auditorium, please no food, and you have to have covered beverages. Okay. All right. Anything else? Okay, that's all our housekeeping chores. So to formally open Science Boot Camp West, I'd like to introduce Betsy Wilson. Betsy is the Vice Provost for Digital Initiatives and Dean of University of Libraries here at the University of Washington, with our campuses in Seattle, Bothell, and Tacoma. Her list of accomplishments and awards are almost too numerous to mention, but I'm going to give you a few little highlights. She has served as ACRL President. She is a past member of the Board of Trustees of OCLC. She's the past chair of the Orbis Cascade Alliance. She's the past chair of the Greater Western Library Alliance. And she's currently a member of the governing board of HathiTrust. And she's also the recipient of many, many awards, including the ACRL Academic and Research Librarian of the Year. And of course, she is and always has been a great supporter of science libraries. So it is my great pleasure to introduce Betsy Wilson.
Hello, everyone. It's great to be here. This is a wonderful venue. This is newly opened about a year ago, and I think it's one of the first conferences to be held here. So we're going to kick its tires a little bit. So thanks, Maureen. And once again, welcome to Seattle, University of Washington, and the Science Boot Camp West 2014. I tried to find my lariat. Isn't that what it was called? Those things you made out of those little lariat with the whistle on it? Because I was a camp counselor for many years. But I think my mother probably threw it away, you know. But anyway, welcome to the camp. I also welcome you to the land of the good rain, which we're not going to see any of when you're here. We'll see the bluest skies you've ever seen. I welcome you to the land of obsessive compulsive recycling, the land of giant octopi roaming the floor of Puget Sound, the land of Sasquatch, maybe known to you as Bigfoot, haunting the North Cascades, the land of geoducks, orcas, and our sacred salmon, and of course the land of coffee on every corner. Also, I welcome you to the birthplace of Boeing, Microsoft, Amazon, Costco, REI, Starbucks, and Nordstrom's, and many, many more institutions. And I welcome you to the home of the likes of Jimi Hendrix, Tom Robbins, Bruce Lee, Quincy Jones, the late, great August Wilson, and our patron saints, Bill and Melinda Gates. The University of Washington Libraries is so pleased to be hosting and contributing to this boot camp. And as I said before, it's so wonderful to have you all here. Whether you hail from the Pacific Northwest and you've seen Sasquatch before, or whether you're from parts further flung. We've been waiting for you. The team has been working very hard for many months to put together a camp that is meaty, meaningful, and motivating. And I don't think you will be disappointed. I am disappointed, however, that I have to leave after our first session to go to the Orbis Cascade Alliance meeting down in Portland, where many of your colleagues are right now, because I just think the lineup is terrific, and I'd love to sit and just soak it all in. You're going to be engaging with leading scientists, researchers, and authors who are passionate about their work, and I'm sure that will be conveyed to you. And we're grateful to each of them for their willingness to participate in something during the summer when they maybe want to be out in the field, and their gift of time and expertise. I can think of no better venue than Seattle and the University of Washington for this boot camp. If Seattle is the right venue, which I believe it is, then Brian Atwater is the perfect opening speaker. And it is with great privilege and admiration that I introduce him to you. Dr. Brian Atwater has worked as a geologist with the U.S. Geological Survey since 1973, and he's been an affiliate professor in the Department of Earth and Space Sciences in our College of the Environment at the University of Washington since 1986. He is perhaps best known for using coastal geology to help identify and define earthquake and tsunami hazards in the Cascadia region, which includes British Columbia, Washington, Oregon, and California. He is a member of the esteemed National Academy of Sciences and the author of many publications, most, maybe not notably, but perhaps most well known to the lay science world, the book, The Orphan Tsunami of 1700, Japanese Clues to Apparent Earthquake in North America. If you haven't read this, you should read it. I'm sure you will after this if you haven't. This book presents the evidence for a major earthquake in the Pacific Northwest on January 26, 1700, which was caused by slippage in the offshore Cascadia subduction zone. This earthquake was powerful enough to produce a tsunami that reached the shores of Japan and was reported in contemporary reports from Japan. His publication Recurrence Intervals for Earthquakes of the Past 3,500 Years at Northeastern Willapa Bay won the Geological Society of America's Kirk Bryan Award in 2000. Dr. Atwater has been interviewed about his research on NPR multiple times, and Time magazine selected him in 2005 as one of the 100 most influential people in America. We have a special treat today. In addition to Dr. Atwater, he will be joined by two visiting researchers from Pakistan. Din Mohammed Kakar from the University of Balochistan. Say that again. Balochistan. And Hazala Naim, a Husner Fellow through the Earthquake Engineering Research Institute from Islamabad. Together they are going to provide us with multiple perspectives on earthquakes and tsunamis. So join me in welcoming our opening trio.
We want to go to combine the house, and I could have done that.
That's okay.
And which one, Dean?
The last one.
Good. Let's start with the cats. That one.
That one, okay.
There you go. Good. Okay, well, thank you. It's an honor to be here. I'm the warm-up act. The real stars are about to stand up. Betsy, thank you. I have to say, in the case of Time magazine, the Indian Ocean disaster 2004 just happened, and Time was looking for a feel-good story about the 2004 disaster that had, of course, an American event angle, because for Time magazine, the universe revolves around the United States, and so they named those people, right? But they wanted something that was related to 2004, so they could point almost with pride, but it's a little, it cometh before the fall, right? Of how in this region, with some help from Japan, it was possible to figure out that very big earthquakes and tsunamis can happen in the absence of historical records here, aside from Native American tales. That, yes, in the absence of that kind of information. So it was geology here. So I was a representative of that, but they stuck me on the same page as Karl Rove. So he was a right-wing, I don't know. He was he with the Bush administration? Yes, he's kind of, you can imagine. Okay, so all right. So briefly, the intro. In a way, our Dean's background, and Professor Dean from University of Balochistan, his background includes GPS, and so this is a Japanese public safety item with a subduction zone and the observant geodesist there. And then Ghazala told me, we have 2 cats in the house there, and they're both staying with me, but Ghazala has had 11 cats, so she can relate to the observant cat, who's also quite, notice the eyes are watching, and you know what's going to happen next, right? So up top it says Jishin and Jishin to tsunami. So it says that, and the idea here is to associate earthquake and tsunami, right? So that if you're on the coast and the ground shakes, you don't wait for the sirens that may have been disabled by falling down or cutting of power, that you know that the earthquake is a natural signal to go to high ground. And you look at the survival rates in Japan in 2011, something like 95% of the people who were in areas in Tohoku, in northeast Japan, that the 2011 tsunami reached, that 95% of those people survived. And a lot of it has to do with this kind of basic understanding of this association. But this can get turned on its head a little bit in the case of tsunamis that ignore international boundaries. And so Betsy described the main story here with Cascadia, and you'll get it better from Sandy Doughton tonight. So I'll just briefly show you that. But the areas we're going to, let's see how to say this. This cartoon map outlines the places where tectonic plates are moving towards one another enough so that when things break, they can make a vertical displacement to the seafloor that lifts the whole water column above it, and then the tsunami happens, okay? And for Gazala and Dean, it's way off to the right there. The little brown line is the Macron subduction zone. And the color code says that it refers to an earthquake in 1945, November of 1945, of about magnitude 8 that happened on the Macron zone. Our zone here is shaded red in a way that it wouldn't have been 30 years ago, at a time when people did not know whether our subduction zone makes big earthquakes. So it was in the early 80s that this was the puzzle. You had this downgoing oceanic plate, you had volcanoes. It was determined by then that the subduction zone was active, but people didn't know whether it was magically lubricated or it was just stuck and nothing had happened since Lewis and Clark. So we have this very short written history that's the problem, right? So you have this map made for the King of France in 1720 with stolen information from the Spanish, showing the west coast of North America as far as Cape Blanco, North Oregon. And north of that, you have no information from the European side. So they're Native American traditions. There's a whole Native American science, you could say, that speaks to the occurrence of very big earthquakes here. It doesn't pinpoint the time and whatnot, but there are reasons from that standpoint to expect it. From a sort of a colonial science standpoint, there was no information about the capabilities of our subduction zone. So geologists like me get into the act, and one of the things that happens with big subduction zone earthquakes is that land levels change, because just what drives the tsunami with the seafloor being kicked up, then also you have wholesale stretching of the overriding tectonic plate that thins the plate and lowers the landscape. And so that's what happens on the Pacific coasts of Washington and Oregon during these big subduction zone earthquakes. The land drops by tens of centimeters, and it's enough for intertidal organisms that are zoned vertically in the intertidal that after the event is over, the land is too low for the plants to become established immediately, and some mud has to build up. But if the tsunami comes in on the freshly downdropped landscape, it spreads that layer of butter there in the sandwich it right. So here you have two school teachers from the Portland, Oregon area, and they're digging at low tide in the bank of a tidal creek out in southwest Washington, Willapa Bay. And the ugly stuff in the foreground is a water-loving glue. It's kind of water as the catalyst, as if you had epoxy and instead of adding hardener, you added water. And so they've painted that substance through a nylon window screen into this bank, and they'll be able to take this home. And the brown part below is the soil of the marsh that was there before the land dropped. And then above that, you see the horizontal stripes. Those are individual sand layers. Probably each represents a different wave in a tsunami wave train the evening of 26 January 1700 by the Japanese dating. And then above that is the plain mud of the mud flat that replaced the marsh because the land had dropped enough that the plants were getting submerged and they no longer preserved. So anyways, they take this back and they use this in classroom. So that kind of work was done here in the late 80s and early 90s. And by the mid 90s, it was clear that from down here in the Eureka, Cape Mendocino area, all the way up to Vancouver Island, that the fault had broken in the decades between 1680 and 1720. We knew that from radiocarbon dating, but we couldn't figure out from this dating whether the whole thing had broken at once in the dinner sausage or whether it was just breaking piecemeal. And this has a big difference in terms of the size of the tsunami. So people who are trying to make maps to forewarn people of how far inland the tsunami could go, they wondered which of these should we use. If they use If they use this one, people are saying, well, they're just exaggerating the hazard just to get research money. Or if they use this one, and the tsunami ends up bigger and people die, then they don't feel very good about that, right? So it's a real quandary. And this is you'll see this is something of an issue for the Macron situation in Pakistan and Iran and Oman, that they have a small break. They have one of these in 1945, and it's not clear whether they're a whole zone, whether they can get a big break like that. So anyways, there we got help from libraries and with help from Japanese researchers. This is a piece of a map from a road map, a highway strip map from the East Asia collection of the University of Berkeley's, University of California, Berkeley Library. And I'm told that the entire thing stretched, unfolded is 40 feet. And it runs, it shows you the road meandering through the middle is the Tokaido, which connected Edo, now Tokyo, where the shogun was, the Tokugawa shoguns, all the way down to Kyoto. And so the strip map shows that whole length. And the castle that left was the retirement villa for the first Tokugawa shogun, Ieyasu. And back there you see Fuji looking like it doesn't look today because the map's from 1687 and there was an eruption in 1707 that changed the shape of Fuji. So this happens to be one of the places where eyewitness accounts come from of this tsunami. The very best eyewitness account actually comes from this pine tree covered peninsula, and it's a gorgeous place where you look up at the it's a case of a village of 325 people and a village chief who had to know how to write and to read because he had to negotiate taxes and he had to record births and deaths and marriages. So he had that information, and there's a collection of writings of the village headman here that was made later in the late 1700s. They must have picked up this pile of paper that was riddled with bookworms and said, oh, this is interesting. We need to copy this out so that future generations know about it. It's very parallel to the interviewing of eyewitnesses in a way that's being done on the Macron coast. You'll hear about. So anyways, it's that kind of information, and this is a different category. These are government documents. You recognize them, and so zasho means miscellaneous records, and this was a case of a group of a samurai family called Nambu that was way up in the north of Honshu, and after they sort of subjugated the place and got control, they established a castle town in the interior, and they kept a book of records. And those are annual records, and as things went on for the samurai, life became more difficult, so they collect their archives become thicker. And I'm told in the Indian situation, as in the time of the British, the volumes become thinner and thinner as the British are leaving India before partition. So here's some of the 1980s, 1990s generation of, or there are multiple generations here of earthquake and tsunami historians. In Japan, there's a whole society of earthquake and tsunami historians. They have annual meetings. They publish a journal. And the leading person is the woman in the, at that time was a woman in the blue hat. She had been a research assistant at the Earthquake Research Institute, University of Tokyo, in the late 1960s, and the Vietnam-era protests spread to the University of Tokyo. A group, a left-wing group, took over the Earthquake Research Institute for 2 years, locked the professors out of their offices. Her professor, she was working for, was a theoretical geophysicist who had a hobby. He liked to collect old documents about earthquakes and tsunamis to learn about Japan's rich history. So for 2 years they went out and they embarked in this, and they came up with lots of information. So for the event in 1700, they eventually collected these different accounts from the places that are numbered there, where Edo refers to Tokyo. And the kind of the punchline that came from it was that the first was the time, the exact time, and second, the approximate size of the most recent big subduction zone earthquake here. So the timing is cartooned here in this computer simulation of the tsunami, that a tsunami traveling at jetliner speeds, like going to Narita Airport, takes from Seattle takes about 10 hours to cross the Pacific. And so they could work back from there. They had Japanese clocks running, and you have to convert those into a Western calendar. You can do that, and you can come up with the evening of the 26th January, 1700. And then the other thing was that there were like in those set of government documents, they talk about houses being washed away by the waves. And that gave an idea of how big the tsunami was in Japan. And from that, it was possible to estimate that the earthquake here was of magnitude 9. Okay? And so the exact time and approximate size to help to define the hazard. So now you can go down the Oregon coast and you can see signs like this that are meant to educate people about what likely happened here. This is a day for night view, since this would have been the night of January evening in 1700, but the native people on the shore, and it's meant to be a...
Can I interrupt you for a moment?
Yeah.
The microphone seems to have gone off.
Oh.
Can we check the... Is this the
How about that? No?
Any different?
No? I'm sorry. I'll just yell.
Well, try it again.
How about now?
Oh, yeah. I'm sorry. Okay. Who didn't hear any of that? That's just a rant anyways. Okay. All right, so and then another, and this has also led to use of other tsunamis. This one, the 1960 tsunami from the south of Chile that went across the Pacific. It took 61 lives in Hilo, Hawaii, and 138 in Japan, and as well as probably 1,000 or 2,000 lives in Chile. So, but the idea was to learn from these past tsunamis and learn from the eyewitnesses how people survived, and then pass that information along in the form of public safety booklets. So that's some of the work at hand. So we'll turn to the little brown area there, the Macron subduction zone now, and I guess Professor Dean, you're the one on stage.
I'm really thankful to the University of Washington for giving me this opportunity to present some very emergently prepared presentation. So, talking after Brian, it is very difficult for me, because he is very, I'm always inspired by his work, and basically we learn a lot from him, and he joined us in Pakistan and that region, and he worked with us for the last 3 years. So we are working, let's to have talk about the region which we belong, and that is the Indian part, Indian plate. So Indian plate, and you have the white strip, that is the Himalaya mountains. In the western part we have Pakistan, and this Himalaya have 7 countries, which Nepal, Bhutan, Sri Lanka, India, Pakistan. Because of the movement of this Indian plate towards north, and causes this huge Himalaya mountains because of this plate collision. So the northern part and the western part have number of big earthquakes in the history. And when we say in the history, so it will happen in the future as well. This is the scientific thing which you can see the major earthquakes along the plate boundary in the northern part of the Himalaya and in the eastern part, western part in Pakistan. So these are all the major earthquakes occurred in this region and caused millions of people affected and killed in this region. Now we are going to focus on the Pakistani side, and that is the Himalaya, which is rising about 5 centimeters per year. So it's going on and the process is going on. So because of this movement, the energy stored in the crust and then afterwards it came into the form of earthquake. You can see this is the western part of Pakistan where we have a line of a Landsat image. In this image you can see this is the Indian and Eurasian plate boundary, which have number of earthquakes in this region in its history. It's moving like left lateral movement it have. So in 1892 there was an earthquake at that point where you can see the displacement of the railway track in 1892. There was an earthquake in Quetta in 1935 when we were the rule of British in that time. So this was a cantonment city, and at 3 at night there was an earthquake which killed 30,000 people within 30 seconds. So it means in the future still lies the earthquakes, and they will again happen in this region. And you can see the photograph of the same city, and it is the same picture of that before earthquake and after earthquake. And you can see clearly the devastation in this city. There was another earthquake in 2005 in northern Pakistan. So very happy city was just become ruins within seconds, and you can see the same picture, the same view. Then this is Quetta, which I was just talked before. It has 2 active faults running through this valley, and both are. One was the causative of 1935 earthquake. And this is the Makran, which Brian already said something about it. And we have number of earthquakes in more recent times. The one in 1945, and then we have in 2011 7.2 earthquake, and then near to the Iran border we have another earthquake. So these earthquakes are just within 3 or 4 hours. In the 4 years time span, these occurred in this region. There was an earthquake on 24 September 2013 which killed 400 people, in Atwater. And this is a picture of that. You can see the image, the fault is running like this, and it ruptured the whole mountain belt about 185 kilometers. And this was an earthquake of very devastating. So you can see the ground picture of the same earthquake, and you can see the lands. One side is up about 1.5 meters. There is another. You can see the image, satellite image, displacement of the stream, and it's horizontally moved 6 to 10 meters. And then another displacement horizontally and vertically of the same fault. This is, you can see, for 195 kilometers. So then there is another plate which is subducting under the erosion plate, that is the Arabian plate. And you can see there are different stars showing the different areas. So that was the tsunami which was just Brian said. There was a tsunami in 1945, an earthquake and then followed by tsunami, and hit these all the 4 countries. And the casualties is this area was at that time sparsely populated, but the casualties range from 300 to thousands of in this area. So these are the names which the area have, and there is an emergence of island always in Makran. We have in 1945, in 1999, and in 2012. We occasionally have this kind of phenomena, the emergence of island in the sea. And this has a 2 to 3 kilometer wide island, and after some time it does just disappear by the wave erosion. This is Gwadar, and you can see it is just near to the source of the 1945 tsunami, and it is just about 3 to 4 meter above the sea level. So you can see the risk these people have in this region. Just a slide to show you the comparison of the resilience of the people. In 2010, there was an earthquake of 7 where the 223,000 people were killed, 8% of the total population of Haiti. And another, in Chile, there was more major earthquake, the 8.8, which killed only 802 people. And then in Quetta, we have 35,000 people killed in that region. So the resilience of the people about the building construction, they have, for example, in Chile, in 1960 there was the biggest earthquake in the history of the earth. So there was that earthquake killed a number of people, but after that the Chile got the building codes, and they just, so because of that you have less casualties, 8.8 earthquake in Chile, and in Haiti, which have poor construction system, and same as in Quetta. just a little bit about the libraries and the record we collected through the 4 countries. So and we have a project of UNESCO where we have visited 4 countries: Oman, India, Iran, and India. So looking for the records and documents, this was the important task we have in hand in the libraries of these countries. But in that part of the world, we also have bureaucratic channels which don't allow the researcher to give the opportunities to have access to the record. So I just wanted to share a little bit the formalities they have. I got this letter for India from the Pakistan High Commission to get the permission for visiting the archives. So I just fulfill all the requirements and then fulfill that the for forma and all other things. And then I collected, I asked for the documents that I need these documents to see, to cite. And what they responded me, they responded me that the documents belongs to Pakistan and Pakistani territories for which they have set rules for the foreigners Pakistani regarding specific document for the citing, consulting of the documents. So they asked me to limit my access to only published and tsunami related, because I filled the form that I need earthquakes and tsunami related material. So the word of tsunami was not there in 1945. So they just told me that you are asking for it. So they just refused because there was no word in that document of tsunami. And then they showed me a list of rules that forbid me to see these documents. And you can see the bureaucratic people, that is the Director General of India, National Archives of India, that guy, and this is Pakistani guy who are sitting there, and he is the Director General of Geological Survey of Pakistan. And both were refused to give me access to their libraries. But the people who are the eyewitnesses of 1945, I get more valuable information from these people. And this is, thank you for your attention. Can you open?
Oh yeah, we need to change the file.
Hello, I'm Ghazala, and I'm really honored to talk to such wealthy and rich people like you, because I guess most of you are responsible for managing wealth of knowledge in libraries. So this is really a great chance for me to talk to you and sharing my experience as a disaster management practitioner. When I come through for some reference or some investigations in libraries, what happens to us? Well, as we have been discussing 1945 tsunami case, this is an ongoing research project of UNESCO. So I think it's better to carry on this discussion. For me, disaster in libraries, if I talk about 1945 tsunami, so it's Makran tsunami and libraries, because most of the research is dependent on the material available in the libraries. What happened to us, in fact, this research was initiated by the material available and the different records available in the libraries. This is the Sindh Observer, the newspaper of 1945, and it shows that quake shocks in Sindh town reported life loss and many other damages. And then further, later in the week, it says 40,000 people landed homeless and maybe 4,000 or thousands of people died. But there was a controversy, and if you see on the left top, you can see that 300 to 350 people died. So there was a huge difference. Either 4,000 people died or 400 people died. And this initiated this research, basically. And we've gone through all the difficulties, as Professor Dean has shared earlier. And why we need this? Because the Makran coast is now densely populated. Once it was scarcely populated. If the damage in 1945 is known, the actual damage, we can develop a scenario for the present day. What could happen to the Karachi, which is the now a very fastly growing megacities in the world, and it has a population of 220 million? Sure. So this is a question for us. So you can see this from 350 to now, the other paper, Dawn in Karachi, it says 4,000 killed in this by the tsunami. So libraries encourage these investigations. So we need to search for official records, newspapers, and scientific papers, which all we went to the Pakistani, Iranian, Indian, Omani, US and UK's library even. And still we are searching for more, and it's not yet a satisfactory result. And then there's another way of finding out the facts. Like Professor Dean said, we went to the people who were the eyewitnesses of these earthquake and tsunami. So we had around 78 of the eyewitnesses along around 1100 kilometer coast of the Pakistan. We found scientific notes like India Meteorological Department. They say something about the Makran earthquake. And then we have, again, the newspaper, Times of India, and it says more about the Indian side, Bombay. Then, during our search, we come across the diplomacies of the time, at that time, what were happening at that time. In fact, there were a revolution of India being divided into Pakistan and India. So, and the Britishers were there, and they were about to leave. So there were difference of like interest, yes. So it is a report from government of Sindh, the governor, and it clearly says, it is not, that this is the text from that. The alarming reports sent out by the party of the congressmen were much exaggerated because they were of the opinion of thousands of casualties. And on the other side, the government, British government, they were about to leave, and they have lost interest in Indian side. So they were of the opinion of 350 and 400. So they said these reports were much exaggerated by local congressmen, and government has issued press notes giving the facts so far as they are known. And they said nothing remained of the place. The governor report is saying nothing remains of the place where some of the villages were. But still, they were of the opinion of the least count. The houses swept away by the water were mostly huts of small value, and most serious loss of these people is the loss of their fishing nets, and which is never reported by the eyewitnesses. They were mostly said there were many deaths, and there were huge loss of boats, their livelihood, and it's not reported here. So in this way, the libraries revealed the priorities of the stakeholders at that time. As I shared that it's an administration report from Persian Gulf and the political agent of Muscat. There was the Gwadar, the town showed by, in a slide by Professor Dean, surrounded by water from two sides. So it has two administrations, one from Sultanate of Oman and one British government. So this report is from political agent of British government, and it says that Gwadar has 3 life lost, and you can see the short the report is, how short this is, about as compared to the incident that happened. And it also reveals that when I come across the libraries, I'm not being a disaster management practitioner. I know about Quetta earthquake in 1935, and I have some details, but I was surprised to find out the details they have now even in the libraries. In 1935, British, they have their interest in the country and very strong communication network. So at that time they have, immense amount of the information. Even they have reported that 16 traders from Afghanistan came to Quetta and they were injured. You can find out the whole of the detail, where they were kept for treatment and how did the government manage their railway passes and how they were brought home back. So minor details were available for this earthquake. But after 10 years, in 1945, when we are supposed to have more information, stronger communication networks and stronger records, but it was not there, just because of the priorities of the stakeholders. So the libraries may lack this kind of information because of the situation going on in the country. You can see this is a picture from Balochistan Archives Library, and we find an administration report here. These are the two or three, and you can see it starts from the thickness of the volume of the administrative reporting has gone thinner, and we found 1945 there up there. So the reports being generated by the officials were stronger earlier in 1900s, and then it's going thinner in 1945 when there was a Second World War going and the British were about to leave. So that was the problem why we are not getting closer to the final results of this research. This was something about 1945 tsunami, and now I have another source of information which I use most of the time. That is e-library or internet. Being a disaster management practitioner, whenever I have to design an awareness campaign, for example, I was given an assignment to work on Gwadar for tsunami evacuation and tsunami mitigation activities. And this is the part of the country which has the least literacy rate and income, per capita income. So in Pakistan, it was the first ever community-based disaster management program, and I could not find anything from the libraries what to do. And it was my first assignment on tsunami. I did some work on earthquake, even on Kashmir earthquake, and I had some knowledge about that, but what to do? So the internet was a very good help for me. So I tried to find out from the website of the organization what others have done on the tsunami. So you can see I searched many things from UNESCO, USGS, Tsunami Teachers is a 534 pages kit, and it's another UNESCO IOC pamphlet. And I think I had to buy another hard disk for such kind of data which was available there. And to go through all these took a lot of time, but it gave very good information for me for an area where tsunami mitigation has never been done before, and where we are going to launch the first ever tsunami awareness campaign. So what I did, I took an inspiration from all of that work. And sometimes I just translated the information of the posters, which are the natural signs of the tsunami and what to do when you have an earthquake in coastal areas, or some other posters. And I developed a booklet for high school students as well as for primary school students based on those information from the e-libraries and websites. I got some videos of scenario. It is a Japanese inundation model, and I use this as a very important tool in my awareness campaign. It shows the inundation level and everything when it is run. Then again, there's a Save Your Life video from Japan. It was in English, and I dubbed in Urdu, in our local language. So all these material were used for when I talk to government officials, all other stakeholders, even NGOs. He's the commissioner of the area who's speaking. And you can see the persons in uniform, in Navy guys. And then all this material was used to run high school awareness campaign, where we trained almost 18,000 students, and we distributed around 50,000 of cartoon booklets, tsunami cartoon booklet, among these children of coastal area. Then the same material with a little bit of adaptation was used for university students who were the native of the coastal area but studying in other universities. And then we designed a media campaign of radio messages and a drama based on all this knowledge that I got from this. Thank you. Yeah, any questions?
Yeah. So you have time for...
So we have time for some questions. So you can ask questions of any of our three presenters, and maybe they can pass the mic to answer. So we'll go ahead. Yes. Right there.
What is the coastal geography like there? Is it a reasonable, most people will get away tsunami, or is it really going to be hard getting people out of those areas in time? How long are you going to have between an earthquake and a tsunami hitting?
It happened in 1945.
Yeah.
And maybe for 100 time return scenario of the earthquake, maybe we're waiting for the next one.
Yeah, no, I'm asking how much time will people have to get away?
Oh,
when one
yeah,
happens?
it's a.
And will they be able to? Is it flat?
Yeah, some part of the country, the coastal region is just flat. That is the Indus Delta, which is almost the same part of the coastal region. That is almost flat area, and rest of the Balochistan part, which is some hilly, and there are some of the places where the water can inundate into the ground, the land. So we have different kind of topography.
And the approximate time is around 20 minutes, 20 to 30 minutes.
20 to 30 minutes is the source
For the local tsunami.
for the local.
I'm glad to hear that you're finding ways of getting the information to actually create these information programs from scratch. And we all have to start somewhere. It looks like you're actually getting momentum, but it's still in such a new process. I'm from Oregon, and in response to all the newest data, which tell us we could die at any time, essentially, a lot has happened since 1995 in the data for the West Coast. There's lots of efforts going on about building tsunami-resistant structures. Japan's gone a long way with this. Oregon's kind of got a couple of projects going, but money is always an issue. Have you even been able to have that kind of conversation start in Pakistan?
Yes, yeah, that's why we invited all the stakeholders, including the government officials and the people from development authorities. So that's why, because there's a new port, Gwadar, in that city, and there's a plan to expand that city a lot. So that we initiated these kind of talks and risk assessment studies in there, because of the priorities of the donors, because the government has a very little amount to spend on the mitigation activities, like tsunami, which has not happened since 1945. So they are dealing with the floods and everything almost every year. So they're spending there with the donor, because this project was done by UNESCO and UNDP in Pakistan. Since 2011, they have stopped funding on the tsunami because they said we don't need to spend on tsunami anymore. You have done enough. So it's more to convince the donor rather than of the government officials.
So on the, let's see, how to say this, that Ghazala's plane ticket here was paid by the Earthquake Engineering Research Institute, which selected her as it's a small group of people. It's like eight people. So and the Hausner Fellowship is for people probably of Ghazala's generation, roughly, who are really pushing the frontiers on earthquake and safety. And the preceding class to yours had an engineer who's based across Lake Washington in Bellevue, who designed an elementary school whose gymnasium roof is going to serve as a vertical evacuation structure, and it may precede anything that's actually going. I don't know. It may be the first, even Washington and Oregon. And in this case, the money was raised locally. This school district in Pacific and Grays Harbor counties, which are not particularly affluent, the school district, the Acosta School District, voted last April to add enough money to the budget for constructing this new school. It was like a 5% increase in the price to provide this vertical evacuation structure. And the school sits right next to the middle school and the high school. So it's, and the area is one that, you asked about whether there are places where people have no place to go. So this is one of those places on the Cascadia coast where it would be very hard for people to get out of harm's way. There's no easy access to high ground, so they are creating it in that special case. There are, of course, a lot of examples of those kinds of structures in Japan and in Bangladesh for cyclones, right?
Yeah. Even in Pakistan.
In Pakistan also.
We designed the first and developed the first ever tsunami evacuation route as a staircase with certain levels landing, and it's 750 steps almost, and to go up to the single mountain, which is the highest one, just near the population area. And the government allotted 105 acres of land from the most expensive piece of in the area, just after this awareness campaign. And we have designed the first ever disaster risk management park and evacuation site for the city of Gwadar. And the second one is under construction in Sindh area, which is very flat and plain area, and the village near the Indian border. There is a 3-story building for evacuation. It's under construction. So we are doing something somehow.
Yeah. The importance of oral interviews was highlighted in your presentation. Are those interviews accessible to other people? Are they being archived? Are they in written form, recordings, or how are they being protected?
In September this year, this project is going to be finalized, hopefully, and this information of videos and the written transcript of the interviews will be available on the website of UNESCO IOC. There's a special site developed for this.
You should expand on that. What are some of the issues? Like you have an issue, you had an inquiry from UNESCO.
Yes, but yeah, there are some problems as well, because UNESCO have recently asked me if you have gotten the permission, written permission from the eyewitnesses to publish their or put their videos on the website. So in my area, my country, it is just with your social network, with your friends. So it is very difficult in that area to go and have written, document in front of them and just getting it signed. It can put me in trouble, and maybe this kind of limitation may delay the posting of this information on website.
A related question that was posed from the UNESCO, quite worried on how they're going to handle this, is a copyright issue raised by the Times of India. So, was it Ghazala who showed the Times of India slide? Yeah. And so I turned to Dean and I said, she's violating their copyright. Because we received a written note from Times of India saying that they were claiming copyright on their materials from 1945 because the valid copyright would go, I guess, back into the 1920s. And so it's an open question there as to whether we can use, reproduce simply the entire newspaper articles, as you saw there. The other newspapers that you saw in this presentation no longer exist. Karachi newspapers from before partition. And so those are available in this country, hardbound, from the auxiliary stacks, I guess, off campus of Library of Congress. So the images you saw there, I took pictures at Library of Congress of these volumes of those newspapers. But yeah, it's an interest. Because we're dealing with this, with the UNESCO bureaucracy that's being very careful, and they want us to dot our I's and cross our T's. And I can understand they're feeling vulnerable, so they're asking. But in the case of getting the permissions from these eyewitnesses, it's culturally it's not a litigious society. I don't think is my impression that what they're up against.
Yeah.
You said earlier that when you were talking about the subduction under the Pacific Northwest, that activity thinned the plate. Is that right, or did I understand it?
No. Okay, so during the 2004 Indian Ocean the earthquake that was at the start of that disaster, where 250,000 people were drowned on the Indian Ocean shores. Okay, there was a tourist place in Thailand called Phuket. Okay, there was a continuous GPS station operating there, and so they know where it was before the earthquake. And after the earthquake, they found that it had moved towards Sumatra. It had moved towards Africa by almost 1 foot. Okay, and that was part of the overall westward motion of that Eurasian plate over the suddenly broken subduction zone. So the expectation here also is that certainly the Puget Sound area, even as far east as Spokane, if we were to have a repeat of what happened here in 1700, have that happen today, the leading edge of our tectonic plate would move towards the Philippines by 10 or 20 meters. But the rocks stretch like rubber bands enough then that you get this tugging and the displacement towards the Philippines would gradually decrease as you go inland. And the only way to solve that space problem is to pull that rubber band, make the rubber band thinner, and then from that you get the lowering of the land. So that's a very simple way geologists can learn about the Earth. The past occurrence of these big earthquakes is to find evidence for abrupt lowering of land. Ghazala's about to go to this conference in Alaska. She'll be at Girdwood, and at her front doorstep will be these Sitka spruce sticking, some of you have seen them, sticking out of the salt marsh. And that was abrupt lowering of the land during the 1964 earthquake.
But my question really was, does that lead to the possibility of more earthquakes because the plates are different?
Yeah.
Aftershocks. Think of the aftershocks in Japan or in Chile. Maybe you saw that when Michel Bachelet's successor, I can't remember his name, was being, what do you call it, installed, inauguration. There were all these people gathered inside of the building, and there was one of the replicas, the aftershocks of the 2010 earthquake that Dean mentioned. And you have this picture of all these people looking up at the ceiling, wondering if it's going to come down. So aftershocks, yeah, the faults. You have lots of faults that get stressed in different ways after the plates have readjusted, and that's the big effect. But other than that, the stretching is just a sudden undoing of the shortening that takes place in between times. So what's happening here today is that our tectonic plate is steadily getting thicker. Okay.
Is there some kind of idea about how, or outlining of where in the Washington and Oregon regions are the most vulnerable to being, to what lake inland that there might be a concern about a tsunami, or I didn't see that necessarily.
So this in a Macron situation would also be the case, and you have people who are good at computing where a tsunami should go, and they start with an initial assumption of how much the seafloor gets raised or lowered abruptly, okay? And then they make that raising or lowering into an initial condition for the sea surface, and then they let gravity take over, and they let it flow towards the land, and then they have some physics on how that all works, and then they let it come ashore, and they make some estimates of how much friction is going to slow the water down and how it interacts with the topography. Right. So they make lots and lots of these simulations. And the challenge in many ways for us, is for Dean and me as geologists, is that starting assumption. Right? The reason, a big reason for this eyewitness account work at Macron is to limit the creativity of the modelers. Because we're providing them with field observations that will at least help to limit their choices. Because otherwise, with the Macron's earthquake and tsunami, they have almost unlimited opportunity to speculate about submarine landslides as sources and exactly where the fault broke. This is so long ago that this information is very sketchy. And so the colleagues who are working in Pakistan or modeling are they're grasping at straws for something like this. But anyways, that kind of work has been done a lot here. I mentioned that the tsunami modeler would worry about, on the one hand, exaggerating the hazard, and on the other hand, killing people, right? And so that work was already underway here in the early 90s. And then when the Japanese information came in, then we said, aha, if we make a tsunami model here that produces the damage and flooding in Japan, okay, then that should be a realistic estimate of what the tsunami would be like here. And then since that time, it's been determined by some that you can get even bigger earthquakes here than the one in 1700. So now they're talking about sort of shoe-size earthquakes of small and medium and large and extra large and extra large. And if you're the mayor or whatever of a coastal town, the modeler will say, well, what shoe size do you want? The bigger the shoe size, the less probable is going to happen. Most of the earthquakes are smaller than that, but if you want to prepare for the very biggest, we can give you a model that does that.
Yeah.
Yeah, just wondering if any or all of you could talk a little bit about sort of what you think of the newest ideas or the future directions in your own research or in your field, or what's coming down the pipe. It's been interesting to hear you talk about using eyewitness accounts to limit creativity of the modelers. So what do you think is coming next, or new techniques or new research that you might be doing?
Yeah, there are a number of techniques which are we using in Pakistan and with the collaboration of the USA universities, and that is the GPS. So we just install the GPS and that have an accuracy of millimeters to monitor the plates movement. So when the plates move, it's gets storing the energy. It's loading the earthquake. So when we get those readings and those data, so then you can calculate how much it is per year, and then in centuries how much stress can be accumulated by this ratio. So you can calculate the earthquakes related to the magnitude like this. You can, you know.
It's something scientific.
Yeah.
Very.
Oh no, but in your field though, what would be the advances that you want?
In my case, this is something, this information like we developed for tsunami mitigation in Pakistan. It's very limited, and there should be ways to spread it up. And the people who are working in this field, they know, oh, Hazara Naeem has done something, or UNDP has done something. But the libraries, they still lack this information. None of the libraries in Pakistan has this simple messages to be adapted and to be, so until now, I could not be able to do something, but I hope so. People are using internet more and more, even the far-flung area in Balochistan and Gwadar as well. The people have good access now to internet. So I think there should be something easily available because it has a very little cost. Someone in Gwadar has to go to Karachi for high studies, for college and university study. But he or she can get easily this information from the website. So these websites should be introduced in schools and the government organizations. So that is the thing. And most of the success is credited to the schools. I can surely bet if you go even now, it has been almost four years or even more, when I started this campaign in a school of Gwadar. If you go there and ask some of the students about what is tsunami, I'm sure many of them will raise hand and say, it's a series, it's a Japanese word, blah, 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 blah. So this is the best source. And we can train our next generation to use the information available anywhere in the world or which suits best to them. So I think we must focus on schools.
Are there any other? Oh, go ahead.
I was curious about the prevalence of libraries in schools in Pakistan.
Yeah, there are in government schools of big schools they have, but small schools in rural areas they don't have. Maybe a high school. In 2005, earthquake was destroyed. Among many others. So I reconstructed that as a seismic resistant construction later in the reconstruction. So it was 3-room schools. For a high school building, there were only 3 rooms. And later we built 26-room school for that. So in that kind of school, you cannot find a library. But in other urban areas and more populated area, yes, there are libraries with limited stuff available there.
You mentioned the Sitka spruce that was now somewhat submerged, and I've heard that term ghost forest for some of these things. Is there a map of visible subsidence events within, is it Northwest or globally? Things that are visible ponds and things like that are of recent occurrence?
Let's see. The answer, I guess, the short answer is there's not a map that says if you drive down here you can see this. So the challenge with an earthquake that's 300 years ago is that the Sitka spruce, which were the dominant victim of the land dropping here along the Pacific Northwest coast in 1700, they rot out. And if you there's a gas station in Portage. There was a gas station in Portage outside of, it's a little beyond Girdwood where you'll go. And this gas station steadily sank into the marsh, over time. And it was still standing completely in 91, and in 98 it had partly collapsed. And so we had this series of photographs that we could see that the spruce were also disappearing, right? And new baby spruce were taking root on the rebuilt landscape. The tides had brought in silt and built things back up. So that visible evidence in Alaska is also fated to go away. Down here, along part of the Cascadia coast, we have this rot-resistant tree, western red cedar. So there are standing dead trunks of western red cedar that were noticed here, starting in the 1850s with a railway survey where a botanist wanted to give an example of how durable against rot the wood of western red cedar is. And so the famous one is that you have a fallen log of that tree, and then you have an old growth tree that is rooted on that log. It was a nurse log, right? So he gave that example. And his second was that in the tide meadows around Shoalwater Bay, now Willoughby Bay, there are dead trunks of this species only standing. So he saw these things, but most of those got logged. They were next to tidewater, and the wood was still good. And the remaining ghost forests in Washington are rapidly falling down. What's left of the red cedar still standing. And they're accessible only by boat, with one exception. There's a solitary red cedar that you can see from Highway 4 near Rossburg along the Columbia River. But that's the only one I know of. So the bank where the teachers they had painted that grout and they got that nice sediment peel, that's right along US 101. And so it's easy to go out there if you like mud and you get out at low tide and you can dig into that stuff. The evidence just knocks you out once you see it. But it was not until the late 1980s that geologists knew to look for it. So it's a lot of, you don't make discoveries until you know to find them, and that was kind of like that. So yeah, there's a lot of evidence out there, but and there are scientific publications that would say, okay, if you take a canoe down this tide creek and you look there, it's pinpointed on the map as to where it is, so you could go find it. But not I think popular that I know.
All right, well, it's close to our break time, so I think we'll end with questions there. But I want to thank Brian Atwater, Dean, and Ghazala. Thank you so much for sharing. We are supposed to break from 2:30 to 3. The break refreshments have not quite arrived yet, but